Picture a man standing at the edge of the Aegean Sea in 610 BC, watching ships disappear over the horizon. Everyone around him believes gods control the waves, that Atlas holds up the sky, that the earth rests on the back of a cosmic turtle. This man thinks they're all wrong. His name is Anaximander, and he's about to invent something that doesn't exist yet: abstract thought itself. The city of Miletus sits on the western coast of what we now call Turkey, though in 610 BC it's the beating heart of Ionia, the most prosperous and intellectually vibrant region of the Greek world. Ships from across the Mediterranean crowd its harbours. Egyptian traders unload papyrus and grain. Phoenician merchants haggle over purple dye. Babylonian astronomers share their star charts in waterfront taverns. This isn't Athens. This isn't Sparta. This is where the world meets to do business, and where ideas collide like waves against the breakwater. Into this world of commerce and cultural exchange, a boy named Anaximander is born. His father's name is Praxeades. Beyond that, history offers us almost nothing about his childhood. No stories of precocious brilliance, no tales of youthful rebellion. The ancient biographers who loved to embellish the lives of philosophers with miraculous birth stories and prophetic dreams simply shrugged when it came to Anaximander's early years. What we do know is this: the city itself was his teacher. Miletus in the 7th century BC is unlike anywhere else in the Greek world. Most Greek cities are isolated, provincial, dominated by local aristocracies who trace their bloodlines back to mythical heroes. But Miletus is cosmopolitan in the truest sense. It has established more than 70 colonies around the Black Sea and Mediterranean. Its merchant fleet is legendary. Its workshops produce goods that reach from Spain to the shores of India. And most importantly for our story, it attracts thinkers. Among them is a man named Thales. He might be Anaximander's uncle, though the ancient sources contradict each other on this point. What matters is that Thales is asking questions no one else is asking. While priests explain that rain comes when Zeus is angry and thunder announces his displeasure, Thales is studying clouds and trying to understand condensation. While poets sing of Helios driving his sun chariot across the sky, Thales is calculating eclipse patterns and predicting when darkness will swallow daylight. Thales has proposed something radical. Everything in the universe comes from a single substance, not from the whims of immortal gods, not from divine intervention, but from a fundamental material that takes different forms. He thinks that substance is water. It's a reasonable guess. Water becomes ice when frozen, steam when heated, exists in clouds and oceans, and the blood flowing through our veins. Water makes sense as a universal principle. Young Anaximander studies with this man. He learns mathematics, geometry, astronomy. He absorbs the merchant's practical knowledge of navigation and trade routes. He listens to travellers describe distant lands and foreign customs. And somewhere in his teenage years, as he approaches adulthood, he begins to see the flaw in his teacher's theory. If everything comes from water, where does water come from? The question seems simple, almost childish, but it opens a door that no one has walked through before. Because if water is the origin of all things, then water itself must have an origin. And if you trace that origin back far enough, you eventually reach something that cannot itself have originated from anything else. Something that simply is, something boundless, indefinite, eternal. Anaximander calls it the apeiron. The word itself is strange, almost contradictory. A meaning without, Pyra meaning limit or boundary. The unlimited, the infinite, the indefinite. It's not a thing in the way that water is a thing. You cannot hold it, measure it, observe it directly. It's pure abstraction, pure concept, and that's precisely the point. This is the moment Western philosophy begins. Not with Thales, who still grounded his thinking in observable substances, not with the mythographers who came before, who explained the world through stories of divine beings, with Anaximander, who dares to propose that ultimate reality might be something we cannot see, touch, or experience directly, something that exists beyond the boundaries of human perception. Think about what this means in 580 BC, when Anaximander is 30 years old and beginning to develop these ideas fully. The gods are everywhere. Every natural phenomenon has a divine explanation. Earthquakes happen because Poseidon is angry. Crops fail because Demeter is mourning. The very idea that you could explain the universe without reference to divine personalities is not just radical, it's borderline blasphemous. But Anaximander isn't trying to eliminate the divine. He's trying to understand it rationally. The apeiron has characteristics that would be familiar to anyone raised on Greek mythology. It's eternal, never born and never dying. It's infinite in extent and duration. It generates everything else through its own inherent nature. These are divine attributes, but the apeiron isn't a person with desires and emotions. It's not Zeus hurling thunderbolts or Aphrodite inspiring love. It's more like a cosmic principle, an impersonal force that operates according to regular patterns. Here's where it gets truly strange. The apeiron generates everything through separation of opposites. Hot and cold emerge from it, wet and dry, light and dark. These opposites interact and combine to create the world we experience. But here's the crucial part. This process is eternal and cyclical. Worlds are born from the apeiron, exist for a time, then dissolve back into it. Other worlds emerge. The cycle continues forever. Innumerable worlds being born and dying throughout infinite time. We're still in the 6th century BC. Most people think the Earth is a few generations old, that their grandparents' grandparents might have walked with heroes who fought at Troy. And here's Anaximander proposing that worlds have been coming into and going out of existence forever, that our entire cosmos is just one temporary arrangement in an eternal process of cosmic creation and dissolution. The implications are staggering. If this world will eventually dissolve back into the apeiron, then nothing we build is permanent. No empire, no achievement, no monument will last. The pyramids of Egypt, which already seem ancient to the Greeks of Anaximander's time, will one day be dust. That dust will return to the apeiron. And then incomprehensibly far in the future, new worlds will form, perhaps with their own pyramids, their own empires, their own philosophers wondering about origins. But Anaximander doesn't stop with abstract cosmology. He tries to understand the physical structure of the world we actually inhabit. The Earth, he claims, is shaped like a cylinder, specifically a short cylinder where the height is 1/3 the diameter. We live on the flat top surface. The sides and bottom remain uninhabited, extending down into space. And here's the revolutionary part. Nothing supports this cylinder. It floats freely at the center of the universe, held in place not by Atlas's shoulders or a turtle's back, but by its own equilibrium. Why doesn't it fall? Because Anaximander reasons it's equidistant from everything else. There's no direction to fall toward. This symmetry keeps it suspended, motionless, at the center of everything. 2,000 years before Newton formulates the laws of motion, Anaximander understands that an object with no preferred direction will remain at rest. Karl Popper, the 20th century philosopher of science, calls this one of the boldest, most revolutionary, and most portentous ideas in the whole history of human thinking. And he's right, because for the first time in recorded history, someone has explained a cosmic phenomenon using pure reason rather than mythology. The Greeks before Anaximander weren't stupid. They were working with the evidence available to them. The Earth feels stationary. The sky appears to move. The obvious conclusion is that we're standing on something solid, and that solid thing must itself rest on something else. Turtles all the way down, as the saying goes. Anaximander breaks this chain of reasoning by asking a different question. Not, what holds up the Earth, but why should the Earth need to be held up at all? It's a subtle shift, but it changes everything. Once you realize that an object in symmetric equilibrium doesn't need support, you've discovered a principle that applies everywhere. You found a law of nature, but Anaximander's Earth doesn't sit alone in space. It's surrounded by celestial bodies, and here his model becomes both ingenious and completely wrong. After the aperon separated into opposites, he explains, fire and water formed first. The fire created a sphere around the wet earth, like bark around a tree. Then this sphere of fire broke apart into enormous wheels, or rings, each filled with fire, each rotating around the earth at different distances. These rings have holes in them, and what we see as the sun, moon and stars are actually glimpses of the fire inside these cosmic wheels, visible through openings in their outer surfaces. The sun is the farthest away, then the moon, then the stars closest to Earth. He's got the order exactly backwards, but the reasoning is sound given what he could observe. The sun appears as a single, bright disk, so it must be one large opening. The moon goes through phases, so its opening must partially close and open. The stars are tiny points of light, so they must be many small holes in a ring very close to us. Eclipses happen when these holes align or misalign. Thunder isn't Zeus being angry, it's the sound of fire bursting through the wheel's surfaces. Lightning isn't a divine weapon, it's fire escaping when the wheels crack under stress. Everything has a natural explanation. Everything follows predictable patterns. The gods haven't disappeared from Anaximander's universe, but they've been pushed to the margins. They might have set the aperon in motion, might have established the laws that govern cosmic separation and recombination, but they don't micromanage daily events. Nature runs itself. This is what scholars call demythologizing the cosmos, taking the poetic, personal, dramatic worldview of Homer and Hesiod and replacing it with something mechanical, predictable, rational. It's not that Anaximander is an atheist. The concept barely exists in his time. He's doing something more subtle and more dangerous. He's suggesting that we can understand the universe without constantly referring to divine will. Around 575 BC, when Anaximander is 35 years old and his reputation as a thinker is growing, the city of Miletus sends him on a political mission. The colony of Apollonia on the Black Sea coast needs leadership. Perhaps there are disputes among the settlers. Perhaps they need a constitution drafted, laws established, order maintained. The exact details are lost to history, but we know that Anaximander goes, and that he's successful enough that later writers remember him as the colony's founder. This tells us something important. Anaximander isn't some unworldly philosopher lost in abstract contemplation. He's a man his community trusts with practical affairs. He can negotiate disputes, he can design political systems, he can lead. The ancient sources describe him as wearing elaborate garments and carrying himself with dignity and authority. This isn't false pride, it's the bearing of someone who knows his own worth and expects others to recognize it. He's also, we're told, a teacher. Students gather around him. He explains his cosmology, his theory of the apeiron, his model of celestial mechanics. Among these students are names that will themselves become famous. Anaximenes, who will eventually succeed Anaximander as head of the Milesian school, and possibly, though the evidence is disputed, a young man named Pythagoras, who will take mathematical mysticism in directions Anaximander never imagined. But teaching means more than lecturing. It means writing things down. And here Anaximander does something unprecedented in Greek intellectual history. He writes a book in prose, not poetry, like Homer or Hesiod. Not in the elevated, rhythmic language traditionally used for important knowledge. In plain prose, the language of merchants and politicians, the language of everyday communication. The book is called traditionally on nature, though we don't know if that was Anaximander's own title. It contains his entire system, the apeiron, the separation of opposites, the structure of the cosmos, the nature of celestial bodies, theories about weather and geography, and the origins of life. It's the first philosophical treatise, the first sustained attempt to explain the universe in written prose, and almost all of it is lost. Only one fragment survives, quoted by later writers. 34 words in Greek that scholars have debated for 2 millennia. The fragment describes how things that exist must pay penalty and retribution to one another for their injustice, according to the disposition of time. What does this mean? The language is legal, borrowed from the Athenian courtrooms, where citizens sue each other for damages. Anaximander is saying that the elements of nature owe each other compensation for wrongs committed. When hot encroaches too far into cold territory, when dry pushes back wet, there must be a cosmic reckoning. Balance must be restored. Justice must be served. This is remarkable for several reasons. First, it suggests that Anaximander sees moral principles operating at the cosmic level. The universe isn't just mechanical, it's ethical. Second, it implies that change and conflict are fundamental to existence. Things exist in dynamic tension, constantly encroaching on each other, constantly being forced back into equilibrium. Third, it introduces time as an active agent, a disposition or arrangement that ensures justice eventually prevails. The fragment is considered the oldest surviving piece of written Western philosophy, and we have 34 words of it. Everything else Anaximander wrote, every elaboration and explanation and argument is gone. We're left reconstructing his thought from summaries written by people who lived centuries after him, who often disagreed with each other about what he actually said. But that fragmented survival tells us something crucial about how intellectual history actually works. Ideas don't transmit perfectly from one generation to the next. They get filtered through the interests and prejudices of people who come later. People who have their own agendas, their own questions, their own blind spots. The later writers who preserved what they did about Anaximander weren't neutral archivists. They were philosophers with their own positions to defend. When Aristotle mentions Anaximander in his Physics, he's using him as a stepping stone in his own argument. When Simplicius quotes that famous fragment in the 6th century AD, he's a Neoplatonist, trying to show that ancient Greek philosophy anticipated Christian theology. They preserved what was useful to them and ignored the rest, which means we're not really getting Anaximander's thought directly. We're getting echoes, reflections, fragments refracted through centuries of interpretation. It's like trying to reconstruct someone's face from a description given by their great-great-grandchildren who never met them but heard stories. Yet even in fragments, patterns emerge. Take his cosmology. Multiple sources agree on the basic structure, even if they differ on details. Anaximander believed Earth was shaped like a cylinder or a drum, with a height about 1/3 of its diameter. We humans live on the flat top surface. The sides curve down into regions we can't access. This sounds strange to modern ears, but there's logic here. If you're standing in the middle of a flat plane, the horizon forms a circle around you. The sky forms a dome above. The simplest three-dimensional shape that matches this experience is a cylinder. It's wrong, obviously, but it's not arbitrary. It's an attempt to geometrize what you actually see. More remarkable is what holds this cylinder up. Nothing. Absolutely nothing. The Earth floats freely in space, unsupported, not resting on anything, not held by anything. It stays in place because it has no reason to move. It's equidistant from all parts of the surrounding cosmos, so there's no direction for it to prefer. No force pulls it one way rather than another. This is extraordinary. Think about what Anaximander is rejecting here. The traditional answer, the one everyone believed, was that Earth must rest on something. Thales said it floated on water, which raised the obvious question of what the water rested on. Other thinkers proposed turtles, elephants, giant pillars, anything to avoid the terrifying thought that we're just hanging in the void. Anaximander said no. We need no support. The geometry of the situation is enough. Symmetry explains stability. This is one of the first examples in human history of someone solving a physical problem through abstract reasoning rather than mythological narrative. He's not invoking gods or cosmic creatures. He's invoking principles, relationships, mathematical necessity. The Earth doesn't fall because falling requires a direction, and there is no privileged direction when you're at the center of a symmetric system. Karl Popper called this one of the boldest, most revolutionary, and most portentous ideas in the whole history of human thinking. He's not exaggerating. Before Anaximander, the question, "What holds the Earth up?" seemed to require pointing to some physical thing doing the holding. After Anaximander, it became possible to answer, nothing needs to hold it up. The question is based on a false assumption. That's a different kind of thinking entirely. It's the birth of theoretical physics, 2 millennia before Newton. But Anaximander didn't stop with Earth's position. He mapped out the entire cosmos. The celestial bodies aren't scattered randomly across the sky. They're organized into specific layers at specific distances. The stars form the innermost ring, closest to Earth, then the moon, then the sun, farthest away. He got the order backwards, which is understandable given the tools available. But the revolutionary part isn't the specific arrangement. It's the idea that there is an arrangement, that the cosmos has structure, that distances can be calculated and layers can be mapped. And the celestial bodies themselves, they're not divine beings or magical fires. They're wheels of compressed air and mist with openings through which we see the fire trapped inside. When the opening closes, we get an eclipse. When it opens wider, the body appears brighter. The phases of the moon, the changing appearance of the sun through atmospheric conditions, all explained mechanically. Again, the specific mechanism is wrong, but the approach is right. Natural phenomena have natural causes that can be understood through observation and reasoning. You don't need to invoke Apollo's chariot or Selena's journey. You need to figure out what's actually happening. This is what philosophers of science mean when they talk about naturalizing explanation, taking phenomena that were previously explained through supernatural intervention and showing how they might arise from the ordinary workings of nature. Anaximander is one of the first people we know of who systematically applied this approach to everything he observed. Weather, not Zeus throwing thunderbolts, it's wind and moisture interacting according to principles we can investigate. Earthquakes, not Poseidon's anger. It's the earth responding to changes in moisture and temperature. The flooding of the Nile, not divine blessing. It's the result of seasonal patterns that can be predicted. He even tackled the origin of life, and here his thinking becomes truly startling. Life arose from moisture, Anaximander said. The early earth was covered with water. As parts of it dried, life emerged in the transition zones between wet and dry. The first creatures were fish-like, covered in spiny bark living in the shallow seas. But humans couldn't have started as helpless infants. A human baby needs years of care to survive. So our ancestors must have developed inside other creatures, fish-like beings that protected us until we were mature enough to survive on land. Then the protective bark broke open and we emerged, already capable of caring for ourselves. This is not evolution in the Darwinian sense. Anaximander isn't talking about gradual change through natural selection, but he is doing something remarkable. He's reasoning from observed facts to conclusions about the past. Human infants are vulnerable. Therefore, humans cannot have started as infants. Therefore, something else must have happened. Work backward from what you know to what must have been. It's proto-scientific reasoning. Build a theory that explains the evidence. Make that theory testable, at least in principle. Don't accept traditional stories just because they're traditional. Compare Anaximander's approach to the creation myths everyone else was telling. Those myths featured gods moulding humans from clay, breathing life into them, placing them fully formed into the world. They're stories about divine action, and they can't be questioned because gods can do anything. Anaximander asks, given what we know about how humans actually develop, how could we have originated? His answer is bizarre by modern standards, but it's constrained by evidence and logic in a way myths never are. He's wrong, but he's wrong in an interesting way, a way that invites correction and refinement. That's what makes it science rather than mythology. The same pattern appears in his cartography. Anaximander drew a map of the known world, not just the local coastline or trade routes, but the entire inhabited earth, as understood by the Greeks of his time. The Mediterranean, the Black Sea, the coastlines of Europe and Asia and Libya, what we'd call Africa, all laid out in relationship to each other. The map was circular, with the 3 continents arranged around the Aegean Sea, like petals around a centre. Rivers divided the land masses. The whole thing was surrounded by ocean, the great river that encircled the world. Again, wrong in specifics, but the impulse behind it is recognisable to anyone who's ever used Google Maps. Anaximander wanted to see the big picture, to understand how places related to each other spatially, to make the world legible through representation. The map served practical purposes, navigation, trade, political planning, but it also served a philosophical purpose. It made the world an object of study, something that could be comprehended as a whole rather than experienced piecemeal. And he built instruments, a gnomon, a vertical rod that cast shadows, allowing you to track the sun's movement across the sky. By measuring shadow lengths at different times of day and different times of year, you could determine the solstices and equinoxes. You could mark the changing of seasons. You could begin to understand the celestial mechanics governing day and night, summer and winter. This is observational astronomy, primitive but systematic. You're not just watching the sky and noting patterns. You're using tools to make measurements, collecting data, looking for regularities. The gnomon is a scientific instrument, maybe the first scientific instrument in the Western tradition. All of this, the cosmology, the biology, the cartography, the astronomy, flows from a single revolutionary conviction. The world makes sense. It operates according to principles. Those principles can be discovered through observation and reasoning. You don't need to be a priest or a prophet. You need to be curious, careful, and willing to question everything, including your own assumptions. This is what historians mean when they talk about the Greek miracle, the sudden appearance of rational, systematic inquiry in 6th century Ionia. It's not really a miracle, it's the result of specific historical conditions. A maritime culture with wide contacts, an alphabet that made writing accessible, political systems that allowed dissent and debate, an intellectual tradition that valued Sophia, wisdom, and encouraged competition among thinkers. But individuals matter. Conditions create possibilities, people actualize them. Anaximander took the tools and questions his culture provided and pushed them further than anyone before him had. He asked not just, what is the world made of, but why is it structured this way, and how can we know? Those questions opened spaces that would eventually become entire fields of inquiry: metaphysics, cosmology, biology, geography, astronomy, natural philosophy, which would later split into physics and chemistry, and all the specialized sciences. None of this was inevitable. It required someone to take the first steps, to show that these questions could be asked and answered without invoking the supernatural. That someone was Anaximander, a man from Miletus who wore fancy clothes and wrote in prose and thought Earth was a cylinder floating in infinite space. A man whose book is lost, except for one haunting fragment about justice and time. A man who spent his life trying to understand everything and left us with almost nothing except the knowledge that someone, 26 centuries ago, cared about the same questions we still ask. But Anaximander wasn't just building instruments and drawing maps in some isolated tower. He was embedded in a world where philosophy and politics weren't separate domains. Theory and practice interwove constantly, and if you wanted your ideas to matter, you had to engage with the messy realities of governance and power. Ancient sources tell us that Anaximander led a colonial expedition to Apollonia on the Black Sea coast. He wasn't sent as a military commander, he was sent as a legislator, someone trusted to establish laws and constitutional frameworks for a new settlement far from home. Think about what that means. The citizens of Miletus looked at this philosopher, this man who pondered the apeiron and measured shadows, and decided he was the right person to create the legal structure for an entire community. This wasn't unusual for the time. The line between philosopher and statesman was porous. Thales had advised on military alliances. Solon of Athens was both lawgiver and poet, but it reveals something important about how Anaximander was perceived by his contemporaries. He wasn't seen as an impractical dreamer. He was someone who understood order, proportion, justice, someone who could translate abstract principles into concrete social arrangements. We don't know what laws he wrote for Apollonia. The colony's constitution hasn't survived, but the fact that he wrote one at all matters. It shows that the same mind asking, "What is the origin of everything?" was also asking, "How should people live together?" These weren't separate questions. They were different aspects of the same inquiry into order and structure. And here's where that surviving fragment starts to make sense in a new way. All existing things must pay penalty and retribution to one another for their injustice, according to the disposition of time. Most scholars read this as cosmology, as a statement about how natural processes balance each other out. Hot compensates for cold, wet for dry. The universe maintains equilibrium through perpetual exchange and correction. But the language is legal. Penalty, retribution, injustice. These are courtroom terms, words from the assembly and the agora, not the observatory. Anaximander is describing the cosmos using the vocabulary of human justice. Or maybe, and this is where it gets interesting, he's describing human justice using cosmic principles. If the universe itself operates according to laws of balance and recompense, if even the elements must answer for their excesses, then human societies should mirror that structure. Justice isn't arbitrary. It's not whatever the powerful decide it should be. It's built into the fabric of reality itself. The same principles that keep Earth hanging unsupported in space should govern how citizens treat each other. This is speculative. We're reading a lot into one sentence, but it fits with what we know about 6th century Ionian thought. These thinkers didn't separate physics from ethics. They believed that understanding nature would teach you how to live. The cosmos was morally instructive. Its order wasn't just mechanical, it was good, something to emulate in human affairs. Anaximander reportedly wore elaborate clothing. He carried himself with dignity, with what later sources called solemn manners. Some historians have interpreted this as vanity, as the affectations of a man who thought highly of himself. But there's another reading. In archaic Greece, how you presented yourself mattered politically. Appearance signaled status, competence, authority. If you wanted people to take your ideas seriously, if you wanted a voice in civic matters, you couldn't show up looking like a beggar. Thales could get away with being the absent-minded philosopher who fell into wells while staring at stars because Thales was already established, already wealthy. Anaximander, his student, had to work harder for respect. The fancy clothes were strategy, not ego. They said, "I belong in these conversations. My ideas deserve consideration," and they did. By the end of his life, Anaximander was one of the most respected figures in Miletus. When he spoke in the assembly, people listened. When he wrote his treatise on nature, It circulated widely enough that copies made it to Athens, possibly to Alexandria. His students included Anaximander, who would continue developing Milesian cosmology, and possibly Pythagoras, though that connection is disputed. But influence creates vulnerability. As Miletus's power grew, so did threats from the east. The Persian Empire under Cyrus the Great was expanding, swallowing up Greek cities in Asia Minor one by one. By the time Anaximander was in his 60s, Miletus was a tributary state, nominally independent but effectively under Persian control. He spent his final years living under foreign domination. The city that had been a beacon of Greek culture and intellectual freedom was now subject to a vast autocratic empire. Did this affect his thinking? Did he continue his investigations into natural philosophy while Persian officials collected tribute and Persian soldiers patrolled the streets? We don't know. The sources are silent on this period, but the timing is striking. Anaximander developed his ideas about cosmic justice and natural law during the last gasp of Milesian independence. He died around 546 BC, right as Persian hegemony was cementing itself. The world he'd known, the world of autonomous Greek city-states competing in commerce and ideas, was ending. And yet his ideas survived. They travelled. They influenced the next generation of thinkers, who would carry them to Athens, to Elea, to Abdera. The physical world he inhabited collapsed, but the intellectual world he helped create expanded beyond anything he could have imagined. Here's what makes Anaximander's achievements so disorienting when you really sit with it. He got almost everything wrong about the specifics. Earth isn't a cylinder. It isn't floating in infinite space held by symmetry. The stars aren't closer than the moon. The sun isn't a ring of fire with a hole in it. Humans didn't gestate inside fish. The universe didn't emerge from an indefinite cosmic soup through the separation of opposites. Every single concrete claim he made turned out to be false. And yet he's one of the most important figures in the history of human thought. How does that work? Because he established the framework. He showed that you could ask these questions. He demonstrated that natural phenomena have natural explanations. He proved that you don't need myths or gods to account for what you observe. You need careful reasoning, systematic observation, and the courage to propose explanations that might sound absurd. Aristotle, 2 centuries later, would get a lot more right about physics and biology, but Aristotle was standing on foundations that Anaximander helped build. The entire scientific enterprise, this assumption that the world is intelligible, that it operates according to discoverable principles, that human reason is capable of understanding it, starts here in 6th century Miletus, with people like Thales and Anaximander asking questions that sound obvious now, but were revolutionary then. What's the world made of? How did it get here? Why does it have the structure it has? Can we know these things, or are we stuck with stories? The answers they gave were wrong. The questions were right, and the questions matter more. This is why philosophy of science distinguishes between content and method. Content is the specific claims, the particular theories, the concrete models. Method is the approach, the way of asking, the standards for what counts as a good answer. Anaximander's content is obsolete. His method is eternal. Every time a scientist proposes a model, tests it against observation, revises it based on evidence, and publishes results for others to critique, they're following the pattern Anaximander established. Every time someone explains a phenomenon without invoking supernatural intervention, they're working within the naturalistic framework he pioneered. Every time we expect the universe to be consistent, to follow rules, to be comprehensible through careful study, we're expressing faith in principles he articulated. That single surviving fragment keeps haunting me. All existing things must pay penalty and retribution to one another for their injustice, according to the disposition of time. It sounds almost mystical. You could read it as poetry, as a kind of cosmic morality tale, but I think it's more precise than that. Anaximander is describing equilibrium. He's saying that the universe self-corrects, that excesses in one direction produce compensating movements in the other. This is actually a profound insight, even if the specific mechanism he imagined was wrong. Systems do tend toward balance. Actions do produce reactions. Nothing dominates forever without provoking countervailing forces. In physics, we call this conservation laws. Energy isn't created or destroyed, only transformed. Momentum in one direction requires equal momentum somewhere else. The universe keeps its books balanced. Anaximander didn't have these concepts, but he glimpsed the principle. He saw that reality operates according to patterns of exchange and compensation, and he applied this insight everywhere, to cosmology, to meteorology, to biology, to politics. If the cosmos maintains justice through perpetual balancing, then human societies should aspire to the same. If nature operates through lawful processes rather than divine whim, then human laws should reflect that orderliness. If the universe is fundamentally intelligible, then we have both the capacity and the obligation to understand it. This is why his legacy isn't really about the cylinder Earth or the fish ancestors. It's about establishing a way of thinking that treats the world as an object of rational inquiry rather than religious awe. A way of thinking that looks for patterns, proposes explanations, tests them against evidence, and revises them when necessary. A way of thinking that assumes we can know things, that knowledge is possible, that the universe doesn't keep its secrets locked away behind divine mysteries. Before Anaximander, these assumptions weren't obvious. After him, they became the foundation of an entire intellectual tradition, the tradition that would eventually produce Plato and Aristotle, Archimedes and Ptolemy, Copernicus and Galileo, Newton and Darwin and Einstein. Every scientist working today is in some sense Anaximander's heir. He died around 546 BC, probably in Miletus, probably as an old man watching his city lose its independence to Persia. No monument marks his grave, no statues commemorate him. His book is lost, his ideas were superseded, and yet here we are, 26 centuries later, still talking about him, still recognizing that something happened in that city, in that moment that changed everything. A man looked at the world and decided it could be understood. Then he spent his life trying to understand it. That's the long shadow. But legacy isn't just about intellectual lineage. Anaximander didn't only influence how we think. He influenced what we build, how we navigate, how we measure the world around us. His contributions weren't purely abstract. Consider the gnomon, that simple rod stuck upright in the ground. Anaximander brought it to Greece, probably from Babylon, where shadow-casting instruments had been used for centuries. But he transformed it from a timekeeping device into a scientific instrument for astronomical measurement. The principle is straightforward. Sunlight hits the vertical rod and casts a shadow. That shadow changes length and direction throughout the day as the sun moves across the sky. Track those changes carefully, and you can map the sun's annual journey. You can determine the exact moments when day and night are equal, the equinoxes. You can identify the longest and shortest days, the solstices. Why does this matter? Because suddenly you have a way to standardize time across different cities. You can coordinate agricultural activities, you can plan religious festivals, you can navigate more accurately. The gnomon turns the sun into a clock that everyone can read. But Anaximander wasn't satisfied with just tracking daily time. He used his gnomon at Sparta to demonstrate the broader patterns of celestial motion. He showed how the sun's position at noon varies throughout the year, how shadows lengthen in winter and shrink in summer, how this variation is regular, predictable, lawful. This is science in action. Not just theorizing about the cosmos, but actually measuring it, testing predictions against observations, building instruments to extend human perception beyond what the naked eye can detect. And the astronomical implications were profound. By tracking the sun's movements precisely, Anaximander could calculate the length of the seasons. Not approximately, but with real accuracy. He discovered they weren't equal. Summer and winter have different durations. This observation alone required explanation. Why would the sun move at different speeds through its annual cycle? The answer, we now know, has to do with Earth's elliptical orbit and the tilt of its axis. Anaximander didn't have those concepts, but he identified the puzzle. He recognized that the heavens operated according to mathematical relationships that could be measured and predicted. This attitude, that nature's patterns can be quantified, would become fundamental to the scientific revolution 2,000 years later. When Galileo dropped weights from towers, when Newton calculated planetary orbits, when Einstein worked out the curvature of space-time, they were all assuming something Anaximander had demonstrated with a stick and its shadow. The universe speaks the language of mathematics. Then there's the map. Anaximander created the first known map of the entire inhabited world. Not a regional survey, not a route guide for merchants, a comprehensive representation of all known lands and seas. Think about what that requires. You need to gather information from travelers, traders, sailors. You need to compare their accounts, reconcile contradictions, fill gaps with educated guesses. You need some system for representing three-dimensional geography on a two-dimensional surface. You need to decide what to include, what to emphasize, how to handle uncertainty. These are cartographic problems that still occupy mapmakers today. Anaximander was solving them in the 6th century BC with no precedent to guide him. His map showed 3 continents, Europe, Asia, and Libya, Africa, arranged around the Mediterranean Sea and enclosed by a vast ocean. The Aegean was near the centre, which makes sense from a Milesian perspective. Rivers marked the boundaries between continents. The Phasis River separated Europe from Asia. The Nile separated Asia from Africa. Was this accurate? By modern standards, not particularly. The continents aren't really arranged that symmetrically. The ocean doesn't surround everything in a simple circle. The proportions are wrong. But that's not the point. What matters is the ambition. Anaximander was attempting to visualize the entire known world as a coherent system. He was saying that disparate regions connect to each other in understandable ways. That space itself has structure. That if you gather enough information and think systematically, you can represent reality in a form that reveals patterns invisible to anyone standing at a single location. The map served multiple purposes. It helped with navigation and trade. Milesian colonies were scattered around the Mediterranean and Black Sea. A map showing how they related to each other geographically would be invaluable for coordinating commerce and communication. It also served political goals. Thales had been trying to organize the Ionian city-states into a defensive federation against the Median threat. A map that showed these cities as a natural geographic unit might help that argument. See? We're not just random settlements. We're a coherent region. Our unity is written into the landscape itself. But beyond practical applications, the map embodied a philosophical principle. Knowledge for its own sake. The desire to represent reality accurately just because that's worth doing. This might be the most important purpose of all. Anaximander was saying that understanding the world is a human good, independent of any immediate benefit. That drawing accurate maps, measuring shadows, proposing cosmological theories, these activities have intrinsic value. We should pursue them because we're the kind of beings who can understand, and understanding is what we're meant to do. This idea would become central to Western intellectual culture. The notion that truth is worth seeking for its own sake, that knowledge is its own reward, that humans have both the capacity and the obligation to investigate reality. These aren't obvious claims. They require justification. Anaximander provided it by example. His student Anaximenes would continue the tradition, where Thales had proposed water as the fundamental substance, and Anaximander had proposed the boundless. Anaximenes suggested air. Everything is ultimately condensed or rarefied air. When air condenses, it becomes cloud, then water, then earth, then rock. When it rarefies, it becomes fire. This might seem like a step backward. Air is more specific than the boundless, less abstract, less philosophically sophisticated. But Anaximenes was trying to make the theory more concrete, more testable. He wanted a principle you could actually work with, not just speculate about. And there's something valuable in that impulse. Philosophy needs to connect with physical reality. Theories need to make predictions you can check. The Milesian school at its best combined bold speculation with empirical investigation. They weren't afraid to propose radical explanations, but they also wanted those explanations to engage with actual observations. This balance between theoretical ambition and empirical constraint would become the hallmark of good science. You need imagination to generate novel hypotheses, but you also need discipline to test them against evidence. The Milesians at their best embodied both. And then there's Pythagoras. The sources suggest he may have studied with Anaximander before leaving Ionia for southern Italy. If that's true, then the entire Pythagorean tradition, with its emphasis on mathematical harmony, its belief that numbers are the key to understanding reality, traces back through Anaximander to Thales. Pythagoras took Milesian naturalism in a mystical direction. He combined mathematics with a religious doctrine, creating a philosophical cult that treated numerical relationships as sacred truths. This wasn't quite what Anaximander had in mind, but it shows how his ideas could be adapted and extended in unexpected ways. The influence spreads outward from Miletus like ripples from a stone dropped in water. Each generation takes the insights of the previous one and pushes them further, sometimes in directions the founders wouldn't recognize, sometimes in ways they'd explicitly reject. But the core commitment remains. Nature is intelligible. The universe operates according to principles we can discover. Knowledge is possible. By the time we reach Plato and Aristotle in Athens 2 centuries later, this commitment has become so fundamental that it doesn't need defending. Of course the world is orderly. Of course human reason can grasp that order. Of course philosophy should investigate nature, ethics, politics, logic, metaphysics through systematic, rational inquiry. These assumptions are the bedrock of classical Greek philosophy, but they weren't always obvious. Somebody had to establish them. Somebody had to show that this approach could work, that rational investigation could produce insights unavailable through myth or revelation, that the universe could be understood through careful observation and logical reasoning. Anaximander was that somebody. Not alone. Thales preceded him. Anaximenes followed him. Countless others contributed. But he stands at a crucial moment in the tradition, the moment when natural philosophy became systematic, when cosmology emerged as a discipline, when the questions got framed in ways that made progress possible. I keep coming back to that cylinder Earth. It's wrong, obviously, but it's wrong in such an interesting way. Anaximander looked at a problem. Why doesn't Earth fall? And instead of answering because something holds it up, he reconceived the entire question. What if nothing needs to hold it up? What if Earth stays where it is because there's no reason for it to move anywhere else? This is the principle of sufficient reason centuries before Leibniz would formalize it. Things don't happen without a cause. If Earth moved in some particular direction, there would need to be a reason. But all directions are equivalent, so Earth remains stationary. The reasoning is elegant. The conclusion is correct. Even if the mechanism Anaximander proposed isn't, Earth really does stay in place without support. Not because it's equidistant from all parts of the universe, but because it's in orbit around the Sun. Gravity keeps it in motion, and that motion keeps it from falling. But the core insight that Earth doesn't need anything underneath it was right. This is what makes Anaximander's errors valuable. They're intelligent mistakes. They arise from applying good reasoning to incomplete information, which means they point toward better answers. A bad theory that's wrong for interesting reasons is more useful than no theory at all. It gives you something to work with, something to test, something to improve upon. Aristotle understood this. When he critiqued the pre-Socratics in his own cosmological works, he treated them as conversation partners rather than primitive fools. He'd explain what they got right, identify where they went wrong, show how his own theory addressed their problems while preserving their insights. This is how intellectual progress happens, through dialogue across generations. And that dialogue continues today. We're still arguing about the same fundamental questions Anaximander raised. What is the universe made of? How did it begin? How do we know anything? What makes an explanation good? These aren't historical curiosities, they're live philosophical problems. Modern cosmology still grapples with the question of origins. What was there before the Big Bang? Where did the initial singularity come from? Some physicists propose eternal inflation. Others suggest cyclical cosmologies where universes are constantly being created and destroyed. Others argue the question is meaningless because time itself began with the Big Bang. Anaximander would recognize these debates. The apeiron as infinite creative potential, the cyclical generation and destruction of worlds, the attempt to explain everything without invoking supernatural causes. The problems have gotten more sophisticated, but they're recognizably the same problems. And we keep making the same mistakes. Not identical ones. Our tools are better, our data more precise, but the same types of errors. We overextend our theories. We mistake models for reality. We forget where observation ends and speculation begins. Take dark matter. We can't see it, can't detect it directly. But we know something's there because galaxies rotate wrong. They spin too fast. The visible matter doesn't generate enough gravity to hold them together. So either our understanding of gravity is incomplete, or there's matter we can't observe. Most physicists bet on invisible matter. They call it dark matter and estimate it makes up about 85% of the universe's total mass. This is pure Anaximander, an invisible substance that we infer from its effects. Not water, not air, not any observable element. Something else entirely. Something that must exist to make the numbers work. We could be right. We could also be completely wrong. Maybe gravity doesn't work the way we think at galactic scales. Maybe our mathematical models need revision. Maybe in 2,500 years, physicists will look back at our dark matter hypothesis the way we look at Anaximander's fiery wheels and think interesting attempt, totally wrong mechanism, but they were onto something. The point isn't whether we're making progress. Obviously, we are. The point is that the fundamental challenge remains the same. We're trying to understand a universe that doesn't come with an instruction manual. We have to figure it out from inside, using tools that are themselves part of what we're trying to understand. Anaximander knew this. That's what makes the apeiron so interesting as a concept. It's not just stuff we can't observe, it's stuff that by definition can't be fully grasped. The boundless, the infinite, the thing that precedes and transcends all particular things. You can't point at the apeiron and say, there it is. You can only point at its effects, the particular things that emerge from it, the worlds that form and dissolve, the opposites that separate and recombine. This sounds mystical. It's not. It's methodological humility. Anaximander was saying we need to be careful about claiming we understand ultimate causes. We can observe patterns. We can track regularities. We can build models. But there's always something beyond the model, something that makes the model work but isn't captured by the model itself. Modern physics rediscovers this constantly. Quantum field theory describes particles as excitations in underlying fields. But what are fields? What's the substrate that does the excitation? Push the question far enough and you hit the same wall Anaximander hit. Something infinite and indefinite that gives rise to everything particular and definite. String theory tries to get around this. Everything's made of tiny vibrating strings, one-dimensional objects in 10 or 11 dimensions. Different vibration patterns produce different particles. It's elegant, it might even be true. But where do the strings come from? What determines the laws that govern their vibrations? You've just pushed the problem back one level. The apeiron still lurks somewhere behind the strings. This isn't a flaw in physics, it's a feature of reality. Or maybe it's a feature of being finite creatures, trying to understand an infinite universe. Either way, Anaximander saw it coming. His theory of opposites is the same thing. Hot and cold, wet and dry. These aren't fundamental substances, they're relationships, properties that exist only in contrast to each other. You can't have hot without cold, can't have wet without dry. The opposites define each other. This is another idea that keeps recurring. Heraclitus made it central to his philosophy. War is the father of all things. Strife creates unity. Everything exists through tension between opposites. Hegel built an entire metaphysical system around it. Thesis meets antithesis produces synthesis. The synthesis becomes a new thesis, meets a new antithesis, produces a new synthesis. History unfolds through dialectical opposition. Modern systems theory talks about it in terms of feedback loops and equilibrium states, complementarity in quantum mechanics, wave-particle duality, the uncertainty principle. You can't measure position and momentum simultaneously because they're not independent properties. They're complementary aspects of a single underlying reality. Anaximander didn't have the mathematics to formalize this, didn't have the experimental tools to test it, but he had the insight. Reality is relational. Things don't exist in isolation. They exist in networks of interdependence. Change one element and you change the whole system. This matters more than you might think, because it changes how you approach problems. If you think things exist independently, you try to understand them in isolation. Study one thing at a time. Control for variables, isolate causes. But if things exist relationally, isolation becomes artificial. You're not studying the thing itself. You're studying a stripped-down version that's been removed from its natural context. The results might not transfer back to the complex system. Ecologists understand this. You can't understand a species without understanding its ecosystem, its predators, its prey, its competitors, its symbionts. Remove those relationships, and you're not studying the species anymore. You're studying something else. Anaximander was thinking ecologically 2,500 years before ecology existed as a discipline. Not in biological terms. He didn't have Darwin's theory, didn't understand natural selection, but in terms of systematic interdependence. Everything connects to everything else. Nothing exists in isolation. His map of the world reflects this too. Not just a practical tool for navigation, though it was certainly that, but a philosophical statement. The known world as a unified whole. Surrounded by ocean, yes, but internally connected. Rivers linking regions, seas connecting continents, trade routes crossing boundaries. The map was wrong in its details. Europe wasn't quite that shape. Asia extended much farther than he knew. Africa was larger than his Libya, but the concept was right. The world is one system. What happens in one place affects what happens elsewhere. Understanding requires seeing the connections, not just the parts. This is still hard. We still tend to think in terms of isolated objects. This rock, that tree, this person. We have to consciously remind ourselves that everything's embedded in larger systems. The rock is part of a geological formation. The tree is part of a forest. The person is part of a society. Anaximander was ahead of us. Or maybe it's fairer to say he was less encumbered by the analytical tradition that came later. The impulse to break things down, separate them, study them in isolation. That approach has been incredibly productive. It's given us modern science, but it has costs. It makes us forget the connections. Mistake our abstractions for reality. The gnomon represents yet another dimension of his thinking. Practical application. It's one thing to theorize about the cosmos, another thing entirely to build tools that let you measure it. The gnomon did that. Simple device, stick in the ground. But used correctly, it tells you things you couldn't know otherwise. When is the solstice? Watch the shadow at noon. When it's longest, that's winter solstice. When it's shortest, that's summer solstice. When it's exactly halfway between those extremes, that's an equinox. How long are the seasons? Measure the days between solstices and equinoxes. Track the patterns over years. Build a calendar that actually corresponds to celestial motions instead of just counting arbitrary days. This is the move from theory to technology, from understanding to application. Anaximander didn't just want to explain the world, he wanted to navigate it, predict it, use knowledge for practical purposes. The gnomon got exported across the Greek world. Other cities adopted it, modified it, improved it. Eventually, sundials evolved from it, devices that didn't just track seasons but divided days into hours. You can trace a direct line from Anaximander's shadow stick to every timepiece ever invented. Technology builds on itself this way. Each innovation becomes a platform for the next one. The gnomon enables astronomical observation. Astronomical observation enables better calendars. Better calendars enable agricultural planning. Agricultural planning enables cities. Cities enable specialized craftsmen. Specialized craftsmen enable better technology. Anaximander stood near the beginning of this process. Not at the absolute start. Thales preceded him. Egypt and Babylon had their own astronomical traditions, but at a crucial acceleration point, when systematic investigation starts yielding practical tools that make further investigation possible. His biological theories show the same pattern. Life originated in water. First creatures were fish-like. Humans developed from aquatic ancestors. Why? Because human infants require extended care. A helpless newborn human wouldn't survive if humans had always been land-dwelling. So there must have been a transitional stage, some kind of protective enclosure, fish that nurtured their young internally. The reasoning is beautiful, even though the conclusion is wrong. He's working from observation, human infants are vulnerable, to inference, therefore humans couldn't always have been this way. To hypothesis, there must have been an earlier form that protected the young until they could survive independently. This is scientific thinking, not the answer, the method. Observe, infer, hypothesize, test. Anaximander couldn't do the testing part effectively. Didn't have fossils, didn't have genetics, didn't have any way to verify claims about ancient life forms. But he had the method. And the method matters more than any particular conclusion. Darwin had the same insight 2,300 years later. Humans didn't always exist in present form. There must have been ancestors, different forms leading gradually to current ones. Darwin had vastly more evidence. He could trace specific lineages through fossil records. He understood the mechanism, natural selection operating on random variation. But the core logic is the same as Anaximander's. Life forms change over time. Current forms descended from earlier forms. The past was different from the present. This is what I mean about intelligent mistakes. Anaximander was wrong about the mechanism, wrong about the specifics, but right about the basic framework. Life has a history. That history involves transformation. Understanding current forms requires understanding where they came from. You could argue Darwin's theory is just Anaximander's theory done right. More evidence, better mechanism, rigorous testing, but the conceptual breakthrough was Anaximander's. The recognition that biological forms aren't fixed, that change is possible. That we need historical explanations, not just structural descriptions. The fragment that survives, pay, penalty, and retribution to one another for their injustice according to the disposition of time, captures all of this. Cosmic justice, things balancing out. What you take, you eventually give back. What dominates now will be dominated later. The wheel turns. It's a moral vision, but it's also a physical one. Matter doesn't disappear. It transforms, gets redistributed, returns to the apeiron, and emerges again in different form. Energy conserves. Systems seek equilibrium. What rises must fall. What expands must contract. We express these ideas mathematically now. Conservation laws, thermodynamic principles, symmetries and invariances. But the philosophical core is unchanged. The universe maintains balance, not through divine intervention, through its own inherent nature, through necessity. That last word matters. Necessity. Not because someone decreed it, but because it couldn't be otherwise. Things happen the way they happen, because that's how things work. The laws aren't arbitrary. They're necessary features of reality itself. This is the final step in removing gods from cosmology. Not denying they exist, just making them irrelevant to natural explanation. The universe runs by itself, according to principles. Principles that can be discovered through observation and reason. Anaximander didn't complete this project. That would take centuries, but he advanced it crucially. Made natural explanation seem viable, showed that you could construct comprehensive theories without invoking supernatural causes at every step. His legacy isn't his specific claims, it's his approach, the confidence that nature is intelligible. That patient investigation yields understanding, that we can figure this out. We need to understand what happened to all this. The ideas, the questions, the method. Where did they go after Anaximander? He died around 546 BC. We don't know exactly how. No dramatic story survives. Just the usual thing. He got old, then stopped being alive, probably in Miletus, probably surrounded by students who'd learned from him. The work continued. His most important student was Anaximenes, younger colleague, fellow Milesian, carried forward the project but with his own twist. Where Anaximander had said the fundamental substance was indefinite, the apeiron, Anaximenes went back to something specific. Air seems like a regression. Thales said water. Anaximander said no, it's something more abstract. Then Anaximenes says air. Why? Because he was trying to solve a real problem. The apeiron was philosophically elegant, but physically vague. How does something indefinite generate definite things? What's the mechanism? Anaximenes proposed one. Air thickens and becomes heavier substances. Gets compressed, turns to water, then earth. Rarefies in the other direction, becomes fire. Same basic substance, different densities. Physical process you can actually imagine. Wrong mechanism, right impulse. Philosophy needs to connect with observation. Abstract principles should explain concrete phenomena. Anaximenes was trying to bridge that gap. Make the theory testable. Give it physical content. The Milesian school continued for another generation. Then Persian conquest disrupted everything. 494 BC, Darius I sacked Miletus, destroyed the city, killed many inhabitants, sold others into slavery. The intellectual community scattered. Some fled to Athens, some to Sicily, some to southern Italy. The geographic centre shifted, but the questions remained. You can trace a direct line from Anaximander through subsequent Greek philosophy. Heraclitus takes up the idea that everything changes, makes it his central theme. You can't step in the same river twice. Reality is flux, constant transformation. The Milesians had said this. Heraclitus made it absolute. Parmenides pushes back, says change is impossible. Reality is one unchanging thing. What is, is. What is not, is not. Nothing can become something else, because that would require it to first be nothing, which is impossible. Complete rejection of the Milesian view, but still engaging with their framework, still addressing their questions. The atomists, Leucippus, Democritus, synthesize both positions. Reality consists of unchanging atoms moving through void. The atoms themselves never change, but their arrangements do. Permanence and flux combined, elegant solution. And notice, they're still working on the problem Anaximander identified. What's the fundamental substance? How does change happen? What principles govern transformation? Plato absorbed all of this. His theory of forms is basically an attempt to preserve Parmenides' unchanging reality while accepting the evidence of constant change in the physical world. The forms are permanent. Physical objects are temporary manifestations. Two-level reality solves the problem by splitting it. Aristotle rejects the forms but keeps the question. What underlies change? His answer is matter and form, potentiality and actuality. Matter persists, form changes. The bronze exists potentially as a statue. The sculptor actualizes that potential. Change is real but intelligible, governed by principles. You can trace it back. The bronze was ore, the ore was earth. Different forms, same matter. Transformation explained. Every major Greek philosopher after Anaximander is responding to questions he raised, either accepting his framework or rejecting it, either building on his foundation or tearing it down and building something else. But the conversation he started continues. The medieval period inherited this through Aristotle. Islamic scholars preserved and extended the tradition. Al-Kindi, Al-Farabi, Ibn Sina, Ibn Rushd, all working within the framework established by the pre-Socratics, asking about first principles, about the nature of change, about how we can know anything certain about a world that won't hold still. European scholars recovered this during the Renaissance, rediscovered the texts, started asking the old questions again. What's the world made of? How does change work? What principles govern nature? The scientific revolution emerges directly from this. Copernicus, Galileo, Newton, they're answering Anaximander's questions with better tools, better methods, better evidence, but the same fundamental inquiry. Copernicus challenges the Earth-centered cosmos, says the sun is central, Earth moves. This contradicts Aristotle, but it's continuous with the Milesian project. Observe nature, build models, test them, revise when necessary. The fact that everyone had been wrong about Earth's position for 2,000 years didn't invalidate the method. It validated it. The method eventually corrected the error. Galileo does something similar. Challenges Aristotelian physics. Says falling bodies accelerate uniformly regardless of weight. Proves it through experiment. Mathematics describes motion. Nature has laws, discoverable laws. This is Anaximander's insight. Nature is intelligible, applied rigorously. Newton synthesizes everything. Universal gravitation, laws of motion, mathematical physics. The cosmos operates by principles. Same principles everywhere. Same principles always. You can write them down. Predict phenomena. Test predictions. Confirm or revise. The method works. But here's what's interesting. Newton's physics eventually got challenged too. Einstein showed it was incomplete. Relativity provides better predictions. Quantum mechanics reveals deeper structure. The theories keep improving. But the method remains constant. Observe, hypothesize, test, revise. That's Anaximander's legacy. Not the specific theories, the approach, the confidence that nature makes sense. That patient investigation yields understanding. That we can figure this out without invoking gods at every step. The Apeiron didn't survive. Nobody believes in an infinite, indefinite substance anymore. But the idea behind it did. There's something fundamental, something underlying apparent diversity. We keep looking for it. Elementary particles, quantum fields, string theory, whatever the current candidate is. Same question Anaximander asked. What's really real? What's the ground of everything else? His cosmology didn't survive either. No cylinder Earth, no wheels of fire, no innumerable worlds cycling through eternal time. But the impulse behind it did. Build comprehensive models. Explain everything with consistent principles. Don't accept mystery when explanation is possible. The evolution theory didn't survive. But evolutionary thinking did. The recognition that current forms have history, that biology requires historical explanation, that we need to account for origins, not just describe current states. Darwin's theory supersedes Anaximander's, but it answers the same question. Where do current life forms come from? Why are they the way they are? How did this happen? Even the fragment, the oldest surviving piece of Greek philosophy, still resonates. Things paying penalty to each other, according to time. Cosmic justice, balance, what you take, you give back. Modern physics expresses this through conservation laws. Energy conserves, momentum conserves, charge conserves. What exists in one form must have existed in another. Nothing appears from nowhere. Nothing disappears into nothing. Everything balances. We don't use moral language anymore. Don't talk about justice or injustice. Don't anthropomorphize the cosmos. But the underlying principle remains. The universe maintains equilibrium, not through conscious decision, through necessity, through the nature of reality itself. Anaximander couldn't have known how right he was. Couldn't have known that 2,500 years later, we'd still be working on his questions, still using his method, still assuming the universe is intelligible, still believing we can figure it out. But he set it all in motion, started the conversation, showed it was possible to think about nature without constant reference to gods, demonstrated that rational inquiry could yield understanding, established the questions that would drive philosophy and science for millennia. The book is lost, only one fragment remains, but the influence is everywhere. Every scientist making observations, every philosopher constructing arguments, every person assuming the world makes sense and we can understand it. They're inheriting Anaximander's vision. You probably didn't know his name before this. Most people don't. He's not famous like Socrates or Plato or Aristotle, doesn't have the popular recognition of Newton or Einstein. But his shadow is longer than theirs in some ways. He came first, made it possible for them to do what they did, created the space where rational inquiry could flourish. Imagine if he'd failed, if the Milesian school had produced nothing useful, if their theories had been so obviously wrong that nobody took them seriously, if the whole project of natural philosophy had died in the 6th century BC, where would we be now? We'd still have religion, still have mythology, still have traditional explanations for everything. Thunder would still be Zeus angry. Disease would still be divine punishment. The cosmos would still be the result of primordial battles between gods. We'd understand nothing, control nothing, predict nothing. Science emerged because a few people in one Greek city decided that natural explanations were worth pursuing. That observation mattered, that you could build theories and test them, that the universe operated by principles you could discover. Anaximander was second in that line, but arguably most important. He systematized it, wrote it down, created a comprehensive framework, showed that natural philosophy could be ambitious, could address the biggest questions. His specific answers don't matter. They're all wrong. But the fact that he asked the questions matters immensely. The fact that he thought they could be answered matters even more. And the fact that he established a method for answering them, observation, reasoning, hypothesis construction, matters most of all. This is what intellectual progress looks like. Not one person getting everything right, but generations of people building on each other's work, correcting errors, refining methods, extending inquiries. Anaximander to Anaximenes, to Heraclitus, to Parmenides, to Plato, to Aristotle, to Islamic scholars, to Renaissance thinkers, to modern scientists, each generation standing on previous shoulders, seeing further, understanding more. The questions remain constant. What's the world made of? How does it work? How can we know? The answers keep improving, but the questions endure. Anaximander asked them first. Or first that we know of. First in a way that started a tradition that continues, that you're part of whether you know it or not. Every time you assume the world makes sense, every time you look for natural explanations, every time you think something through rationally, instead of accepting traditional authority, you're doing what Anaximander did, operating in the space he opened, using the tools he pioneered. That's the real legacy, not the theories, the confidence, the assumption that inquiry works, that nature is intelligible, that we can figure this out. 25 centuries later, we're still proving him right. The modern world doesn't just inherit his ideas, it runs on them. Every time you check the weather forecast, you're assuming nature follows patterns. Every time you trust a medical diagnosis, you're betting that causes produce effects predictably. Every time you expect tomorrow to resemble today in its basic operations, you're making an Anaximandrian assumption. He didn't invent science, but he invented the confidence that makes science possible. Consider what that required. In 550 BC, the default explanation for everything was divine intervention. Thunder, Zeus, disease, angry gods, earthquakes, Poseidon's fury. This wasn't ignorance, it was coherent. It explained everything. It provided meaning and moral order to natural events. Anaximander looked at that entire framework and said no, not because he had better evidence. He didn't have microscopes or telescopes or laboratories. He had his eyes and his brain, and the willingness to trust them over tradition. That's the revolution, privileging observation and reasoning over inherited authority. It failed immediately in specific terms. His cosmology was wrong. His biology was wrong. His physics was wrong. Every single particular claim he made about how nature works turned out to be incorrect. But the method survived, actually thrived. Because being wrong in an interesting way beats being right for bad reasons. Anaximander's errors were productive. They suggested new questions, created frameworks others could refine, established standards for what counted as explanation. Compare that to mythology. Myths don't generate follow-up questions. They provide closure. Zeus threw the thunderbolt. End of story. Nothing to investigate, nothing to test, just accept and move on. Anaximander's theories demanded investigation. If the Aperon generates everything, how? If Earth floats unsupported, why doesn't it fall? If humans evolved from fish, what's the mechanism? Each answer opened 10 new questions. That's generative thinking, creates intellectual momentum, builds communities of inquiry, establishes traditions that outlast any individual contribution. The Milesian school continued for generations. Anaximenes refined the Epeiron concept. Heraclitus challenged it. Parmenides rejected it entirely. But all of them worked within the space Anaximander created. All assumed that rational inquiry into nature was worthwhile. That observation mattered, that you could construct and test explanations. Even the ones who disagreed violently accepted his basic premise. Nature makes sense, we can figure it out. That premise spread. From Miletus to Athens to Alexandria, to medieval Baghdad, to Renaissance Europe, to modern universities worldwide. Different languages, different methods, different technologies, same fundamental confidence. The universe is intelligible. Human reason can grasp it. Natural laws govern everything. You don't consciously think these thoughts. They're background assumptions, part of the intellectual air you breathe. But they weren't always obvious, weren't always accepted, had to be argued for, demonstrated, established through generations of work. Anaximander was second in that process, but his contribution might be the most crucial. Thales started it with water, made the first move toward natural explanation, but Anaximander systematized it, wrote it down, created a comprehensive framework, showed the scope of what natural philosophy could attempt. He addressed everything: origins of the cosmos, structure of the heavens, nature of matter, development of life, shape of the earth, causes of weather, all within one explanatory system, all without invoking gods. That ambition matters as much as any specific insight. It established the template, showed that natural philosophy could be total, could address ultimate questions, didn't have to limit itself to narrow technical problems. Modern science inherited that ambition. Physics tries to explain everything in the universe. Biology tries to explain all life. Geology tries to explain Earth's entire history. Nobody thinks that's overreach anymore. But it would have seemed insane before Anaximander demonstrated it was possible. The map he drew illustrates this perfectly. First known attempt to represent the entire inhabited world, not just your local region, not just the places you'd visited, everything. The whole known Earth on a single diagram. That's not just practical cartography, it's intellectual audacity. It assumes the world has a shape that can be known, that distant places relate to each other in ways you can represent. That comprehensive understanding is achievable. The map was wrong, wildly inaccurate by modern standards, but making it was revolutionary. Established that global thinking was possible, that you could reason about places you'd never seen, that systematic knowledge could transcend direct experience. Same with his evolutionary theory, completely wrong in details, but revolutionary in approach. He looked at the problem. Human infants are helpless for years, and reasoned backwards. If we've always been this vulnerable, we couldn't have survived. Therefore, we must have developed from something else, something more self-sufficient. That's hypothesis construction, abductive reasoning, inference to best explanation, the core methods of scientific thinking. He's deploying them 25 centuries before Darwin. The gnomon demonstrates another dimension, not just theorizing, building instruments, making measurements, using tools to extend human perception. The shadow at noon reveals patterns you can't see directly. The length varies predictably, marks the seasons, makes time visible. That's experimental methodology in embryonic form. You're not just observing nature passively, you're creating situations that reveal hidden patterns, using technology to amplify perception, transforming qualitative impressions into quantitative data. All these innovations cluster in one person, in one lifetime, in one small Greek city in the 6th century BC. That's what makes Anaximander's achievements so remarkable, the sheer concentration of foundational insights. He wasn't working in a vacuum, had Thales as teacher, benefited from Miletus's prosperity and intellectual culture, drew on Babylonian astronomy and Egyptian geometry, but the synthesis was his, the systematic application of rational inquiry to every domain of nature. And he wrote it down. That matters immensely. Oral traditions preserve some knowledge, but writing enables accumulation, enables critique, enables transmission across distance and time, enables intellectual progress. The book is lost now. Only one fragment survives. But its existence changed everything, created a model other thinkers could follow. established prose treatises on nature as a legitimate genre, made philosophy a cumulative enterprise. Imagine the alternative: if Anaximander had kept everything in his head, taught students orally, died without recording his ideas, much would have been lost, distorted in transmission, impossible to verify or build upon systematically. Writing created permanence, created accountability, created the possibility of genuine intellectual progress through generations of scholars building on documented work. That's why the loss of the book is so tragic. We have summaries, second-hand reports, one preserved fragment, but the full argument is gone. The examples he used, the reasoning he deployed, the observations he cited, all vanished, yet the influence remains. Later thinkers reference him constantly. Aristotle discusses his ideas critically but respectfully. Theophrastus preserves his doctrines. Simplicius quotes him 6 centuries after his death. The tradition remembers him as foundational. He's in the genealogy of every major Greek philosopher. Heraclitus responds to him. Parmenides rejects his conclusions but accepts his methods. Empedocles and Anaxagoras modify his principles. Plato and Aristotle treat him as a serious predecessor whose views deserve engagement. That intellectual lineage continues. Medieval Islamic scholars study him. Renaissance humanists rediscover him. Enlightenment thinkers claim him as ancestor. Modern scientists recognize him as pioneering their approach. He's not in popular culture the way Socrates is. Doesn't have memorable dramatic moments. Wasn't martyred. Didn't have famous students who wrote dialogues starring him. Just lived in Miletus, thought carefully, wrote systematically. Died around 546 BC, but his shadow extends further than figures who seem more prominent. He established fundamentals, created the intellectual infrastructure others built on, made it possible for later, more famous thinkers to do their work. That's often how genuine innovation works. The most important contributions aren't always the most visible. The person who establishes the framework matters more than the person who completes the building. The one who asks the right questions matters more than the one who finds the answers. Anaximander asked the right questions. What's everything made of? How did it all begin? How does nature operate? Can we understand it through reason and observation? Those questions drove philosophy and science for millennia. Still drive them today. He also answered them. Wrongly, but productively. The apeiron isn't real. Earth isn't a cylinder. Humans didn't evolve from fish the way he described. But each wrong answer pointed toward better questions. Created problems his successors could solve. That's intellectual progress. Not one genius getting everything right, but generations of thinkers correcting each other's errors, refining methods, extending inquiries, building cumulative understanding over centuries. You're the beneficiary. You live in a world that assumes nature is lawful. That observation yields knowledge. That rational inquiry works. That comprehensive understanding is achievable. These aren't obvious truths. They're hard-won assumptions, established through centuries of work, starting with people like Anaximander. He made it possible, showed it could be done, created the template, established the confidence, demonstrated that human reason could grapple with ultimate questions and make genuine progress. 25 centuries later, we're still following that path, still assuming inquiry works, still building on foundations he helped establish, still operating in the intellectual space he opened. That's the real legacy, not the theories, the possibility, the confidence that nature makes sense and we can understand it. That observation and reasoning can reveal truth. That comprehensive knowledge is achievable. He was right about that, and we're still proving it. Here's what I find remarkable about Anaximander. He had every reason to fail. Wrong time period. Rational inquiry barely existed. Wrong location. Miletus was prosperous but provincial. Wrong background. Son of a craftsman, not nobility. Wrong tools, no instruments, no laboratories, no accumulated knowledge to build on. And yet he succeeded anyway. Not in getting the right answers, in asking the right questions, in establishing that questions could be asked, that nature was interrogable, that human reason had jurisdiction over ultimate mysteries. Think about the courage that required. Everyone around him accepted divine explanations. Thunder was Zeus, earthquakes were Poseidon. The cosmos was the result of divine battles and divine will. This framework worked. It explained everything. It provided meaning and moral structure to existence. Anaximander looked at all that and said, we can do better. Not because he had proof, not because he had evidence that natural explanations would work, but because he thought they should be tried. That's faith of a different kind. Faith in human capacity. Faith in rational inquiry. Faith that the universe makes sense and we can figure it out. He was wrong about almost everything. The Apiron doesn't exist. Earth isn't a cylinder. The stars aren't closer than the moon. Humans didn't gestate inside fish. His specific claims are historical curiosities now. Interesting mistakes, intelligent errors, but mistakes nonetheless. What he got right was the method. Observe carefully, reason systematically, build comprehensive theories, test them against evidence, revise when necessary. Don't accept traditional authority just because it's traditional. Don't invoke gods when natural explanations might work. That method conquered the world, not immediately, not obviously, but gradually, persistently, inexorably. It spread from Miletus to Athens to Alexandria, survived the fall of Rome, preserved by Islamic scholars, recovered by Renaissance Europe, refined into modern science. Every laboratory operating today, every telescope pointed at distant galaxies, every microscope revealing cellular machinery, every computer modeling climate or particle physics or evolutionary dynamics, all of them rest on an Anaximander's assumption. Nature is intelligible. We can understand it. He didn't prove that assumption, couldn't prove it, can't be proven. It's a commitment, not a conclusion, a decision to treat the universe as comprehensible, to privilege observation over revelation, to trust reason over tradition. But the commitment worked, generated understanding, made predictions, enabled technology, transformed human existence. We live longer, know more, control more than any previous generation because people followed Anaximander's path, assumed inquiry works, tried to understand nature on its own terms. The questions he asked remain live. What's the fundamental substance? How did everything begin? How does nature operate? What makes an explanation good? We have better answers now, more refined theories, more sophisticated methods, but we're asking his questions, using his approach, working in the space he opened. That's immortality of a strange kind. Not fame exactly. Most people don't know his name, couldn't identify his contributions, have no idea they're thinking his thoughts, using his methods, inheriting his assumptions. But influence doesn't require recognition. The deepest changes are often invisible. Background assumptions, conceptual frameworks, ways of thinking that become so natural you forget they're not inevitable. Anaximander changed how humans think about nature, made rational inquiry seem possible, established that comprehensive understanding was achievable. 25 centuries separate us from the man who stood at the Aegean watching ships disappear over the horizon. 25 centuries of intellectual progress, scientific revolutions, technological transformations, conceptual upheavals. Everything's different now, except the fundamental commitment. Nature makes sense. We can understand it. Observation and reasoning yield truth. That's Anaximander's gift, not his theories, his confidence, his willingness to trust human reason over divine revelation, his demonstration that inquiry works. He built nothing permanent. His book vanished. His city was destroyed. His theories were superseded. But he started something that never stopped, created momentum that never dissipated, asked questions that never went away. The man is gone, the questions remain. And every time someone looks at nature and thinks, I wonder how that works, and then tries to figure it out through observation and reasoning, Anaximander wins again. Every time someone assumes the universe is intelligible and human reason can grasp it, he's validated, not fame, not recognition, but fundamental influence, changing how humans relate to nature, establishing the possibility of genuine knowledge, creating the intellectual foundation for everything that followed. The cylinder Earth was wrong, the Apiron was confused, the evolutionary theory was backwards, but the commitment behind them was right. And that commitment, that nature is intelligible, that we can understand it, that inquiry works, has proven itself across 25 centuries of human investigation. We're still standing in his shadow, still following his path, still proving him right about the thing that mattered most. Not the answers, the questions, not the theories, the confidence, not the destination, the journey. He showed it was possible. That matters more than getting it right, because once you know it's possible, you keep trying, keep investigating, keep building, and eventually, across generations, understanding accumulates, knowledge grows, truth emerges. That's Anaximander's real achievement. Not solving the mysteries, opening them, not providing answers, establishing that answers exist and we can find them. Not being right, showing that being right is possible. The first philosopher to write in prose, the first cosmologist, the first evolutionary theorist, the first cartographer, the first astronomer using instruments, the first person to systematically apply rational inquiry to nature. All these firsts matter, but they're symptoms of something deeper. The first person to bet everything on human reason, to trust observation over revelation, to assume nature was comprehensible and act on that assumption, to show that inquiry works by doing it, by building theories, by making predictions, by demonstrating that natural explanations could replace divine ones. He was wrong about the specifics, right about the fundamentals, and the fundamentals are what matter. The specific theories pass, the method remains, the confidence endures, the questions continue, from a harbour in Miletus to every laboratory on Earth, from 610 BC to today. From one man watching ships disappear to billions assuming the universe makes sense. That's the arc. That's the legacy. That's the shadow. Anaximander, first philosopher to write his thoughts. Last we can know about with certainty. Everything before him is mythology and speculation. Everything after him is philosophy and science. He stands at the hinge, the moment when human thinking changed direction, when rational inquiry became possible, when nature became something we could understand rather than just experience. He didn't do it alone. Had Thales before him, Anaximenes after, countless others contributed, but he's the one who systematized it, who wrote it down, who showed the scope of what was possible, who asked the biggest questions and assumed they could be answered. The book is lost, the fragment remains. All existing things must pay penalty and retribution to one another for their injustice, according to the disposition of time. 34 words in Greek, the oldest surviving piece of Western philosophy. Everything else about his thought filtered through later writers, distorted by their interests, simplified by their understanding. But those 34 words tell you everything you need to know. Justice operates at cosmic level. Time is the arbiter. Balance eventually prevails, not through divine intervention, through necessity, through the nature of reality itself. That's the insight. That's the revolution, not the specific cosmology, not the particular theories. The recognition that nature operates by principles, that those principles can be discovered, that we can understand. That inquiry works. He believed it, acted on it, demonstrated it, and 25 centuries of human investigation have proven him right. Not about the cylinder Earth, or the Aperon, or the fish ancestors, about the thing that matters. Nature is intelligible. We can figure this out. That's the legacy. That's the shadow. That's why a man dead 25 centuries, whose book is lost, whose theories are obsolete, whose name is unknown to most people, matters more than almost anyone in history. He made it possible, showed it could be done, established the confidence that drives every scientific investigation, every rational inquiry, every attempt to understand nature through observation and reasoning. From Miletus to everywhere, from 610 BC to forever, from one man's question to humanity's project. That's Anaximander.